Number 21. The function f is defined by f of x equals a to the power of x plus b, where a and b are constants and a is greater than 0. In the xy plane, the graph of y equals f of x has a y-intercept at 0, negative 25, and passes through the point 2, 23. What is the value of a plus b? All right, so this is a good example of a question where we really need to know how to do our stuff. There isn't a sort of thing where we can just plug it into a graphing calculator and have it show us the answer. We need to know what's going on here. So let's start with our first function, f of x equals a to the power of x plus b. And it's saying we can graph this when y equals f of x. Okay, so it's just saying if I were to put this in as y equals a to the power of x plus b, these two ordered pairs make it true, 0, negative 25, and 2, 23. Well, I have two constants here, so I want to solve them one at a time. Which of these can I solve by using one of these ordered pairs? Well, anytime there's a 0, I'm intrigued. Zeros have a way of getting rid of things or making things easier when we plug them into equations. So I'm going to plug in a 0 into this equation and see what happens here. So 0 would be my x, and negative 25 would be my y. So does this help me? Oh boy, does it ever. Because even though I still have two constants here that I need to solve for, a and b, what is any number to the power of 0? It's 1. So a to the power of 0 is just 1. So I've gotten rid of one of those variables, or those variables which represent a constant in this case. So I've gotten rid of one of them because I cannot have two variables that I need to solve for in a single equation and do it. I have to get rid of one of them. If I want to, if you want to solve a set of equations, a system of equations, you have to have, in most cases, if you don't have those ordered pairs, you have to have one equation for every variable. So if you have 3 variables you're solving for, you have to have at least 3 equations. It's just how it works. Except when they do things like this and they give you a handy-dandy ordered pair with 0 in it. So negative 25 equals 1 plus b. Let's solve for b. I'm going to do that by undoing what's been done to b. b has had 1 added to it. I'm going to do the opposite, so I'm going to subtract. I do it on both sides to keep it nice and balanced and equal. Negative 25 minus 1 is negative 26. And then I am just left with b on the right-hand side. Like, great, I now know that b is negative 26. But my final end goal is to determine the value of a plus b, so I need to solve for a. Well, now I've got my b, that is negative 26. So I'm going to start with this same equation again, and we're going to plug things in that we know using the second ordered pair, 2 and 23. All right, so let's plug in everything. My x value is 2. I'm going to put that right there, a to the power of 2. My y value is 23. I erase the y and replace that. And finally, my b is negative 26. So there we go. All right, so I want to solve for a. I just have now a sort of straightforward single variable equation that I'm solving for. I want to undo what's been done to a. Since a has been squared and then 26 subtracted, I want to go backwards and undo that. I'm going to do the opposite by adding 26 to both sides. Always both sides with algebra to keep it nice and balanced. So on the left, 23 plus 26 is 49, and that equals a squared because the minus 26 plus 26 cancels out. Now to undo that square, I'm going to take the square root of both sides. So I have the square root of 49 is plus or minus 7, and that is equal to a. So which is my value of a? How do I know? Well, I know because they told me up here that a is greater than 0. So I know it is the positive 7, not the negative 7. So A is equal to positive 7. And now finally I can get my answer. They want to know what is A plus B. Negative 26 plus 7 is negative 19. And that is my answer. Hey guys, this video was helpful or useful in any way. Please feel free to let the algorithm know about it. Like, share, comment, subscribe, even buy me a coffee if you're so inclined. Links for that down below as well. Thank you so much for stopping by. I hope you have a great day. See you later. Bye.